As we start our second lesson, we take a look at what's here, and they're asking which quadrant would this set of ordered pairs be in. And we had said in our lecture that if it's the first quadrant, both coordinates are positive. Second quadrant, and we label them counterclockwise, the x would be negative, the y would be positive. In the third quadrant, both would be negative. And in the fourth quadrant, the x would be positive, the y would be negative. And then things might also be found on either the y-axis or the x-axis. So with this background, and we do get phone calls here at my home desk from time to time, you ought to be able to answer these. So let's pause and let you answer. So 1 would be the second quadrant. 2, that is the y-intercept, so that's on the y-axis. 3 would be, they're both positive, so quadrant 1. Here they're both negative, so quadrant 3. And here this looks like the x-intercept, so this would be on the x-axis. And as a little review, we said the y-intercept has this form, 0, b, and this x-intercept has the form a, 0. This was in our formula chart back in the beginning of this booklet. And of course the answers are on page 25 as well. As we go to the next page, we're wondering, is this ordered pair a solution for this equation in two variables? So the strategy would be to put the y value, I'm going to put a 9 where the y is, minus 13 for the x, plus 9. Does that equal 0? Well, 18 times 9 is a rather big number, and that's not enough. So this one is going to be no. How about this one? Well, again, 14 times 7, which is our x value, minus 2 plus 8. Does that equal 0? Well, again, 14 times 7 is a really big number, so this one's no. And we'll give you a chance to do the others. In number 3, we're substituting this ordered pair members in this formula, which we'll be using later in the course. And this is going to be a 0 then, plus 6, so this is 6. 6 squared is 36. Our y is a 1. 1 plus 3 is 4. 4 squared is 16. Add these up, and I get 52. Now they have a 49, and down below they said this is supposed to be a yes, but I'm going to say it's a no, so that may be an error. All right, let's take a look at number 4. It's going to be a negative 3 times 2, which is our x, plus 2 times 3. Does that equal 0? Well, this is a negative 6, and this is a positive 6. And when we add that up, this checks out. So this is a yes. Now again, you are going to receive a grade for this booklet, so we're looking for this type of work to support your answers. We don't just want a yes or no here, we want to see the substitution and the results. Now, substituting in item 5, the x is 5. So 5 minus 5, this is 0 squared. Minus, now y is a 4. 4 plus 2 is 6. 6 squared is 36. Does that equal 36? Well, here this doesn't count for anything. That's just a 0. And we have a negative 36. Does that equal 36? No. This was on the wrong side of the number line. Okay, on this next page, they want us to graph these linear equations when they are in standard form. Now, they said they were linear equations, so they're going to be a straight line. And we had said in lecture that when we are graphing equations that are in standard form, that we would like you to make this special X and Y intercept T-chart, where here X is 0, and then whatever value you get there will be a B value, which is your Y-intercept. And over here, whatever value you get for X will be an A value, which is your X-intercept. So let's do that. We're going to put a 0 where the X is. So this becomes 0. Divide both sides by 3. Y equals 3. And then here, if Y is 0, 12, divide both sides by 12, we're going to get 9 twelfths, which is 3/4, which is, we'll just put it there as 3/4. So when we go to graph this, we're going to put a 0, 3, 1, 2, 3 right there. And we're going to put a 3/4, 0, which is right about there. So those are 2 points, but trying to graph 3/4 is a challenge. So let's solve this for our Y value and put this equation in slope-intercept form. Y equals mx plus b. So we get 3y equals, transpose that, becomes a negative 12x plus 9. Now divide everything by 3. This will become y. This is going to become a negative 4x plus 3. Dividing each term by 3. Now here I see my slope is a negative 4 over 1, and my y-intercept is 3 that we learned from this special T-chart. But we don't have to worry about plotting that 3/4 now. So we put a dot at 3, and our slope is a negative 4 over 1. So in MATLAB we go over 1 to the left. That's for this negative value down here. And then go up 4. 1, 2, 3, 4. Now another way of doing it is go over 1 and then go down 4. 1, 2, 3, 4. So that's where it actually is on a grid line. So then we take our line tool and just sketch that right in there. And MATLAB will do that very well. Now this next one should work a little easier. We're going to use that X and Y intercept T-chart now, because we're not going to get fractions, because I see both of these are divisible by 4 or 5, the 20. So if X is 0, Y is a negative 4. And if Y is 0, X will be a 5. So this one's relatively easy. So we're going to go 0, negative 4, 1, 2, 3, 4, right there, and then 5, 0. 1, 2, 3, 4, 5. And they take our line tool, and there's our graph. This one, again, we're going to get a fraction, but we'll use that technique. Changed my mind. Instead of getting a fraction, we're going to solve it for y. So we get 2y equals, transpose our 4x to the other side, a negative 4x plus 6. Now divide everything by 2. I get y equals a negative 2x plus 3. So again, we'll use the technique of plotting the y-intercept. A plus 3. 1, 2, 3. Now our slope is a negative 2 over 1. So I'm going to, this is my x value. Remember, slope is y units over x units. So since it's negative, I'm going to go over 1 this way. And then I'm going to go up 2. And I can make more points if I want. Over 1, up 2. Now I can also go to the right 1 and then down 2. Over 1, down 2. So you see, there's my x-intercept right there, which is 3 halves, if you use that little x and y-intercept T-chart. If x is 0, y is 3. See, that's our y-intercept right there. And if y is 0, this is going to be 3 halves. As I divide both sides by 4 here, I get 6 over 4, which is 3 halves, which is right there, 1 and a half. So I have a number of points. I'm going to take my line tool, and there's my graph. Now this one would work out very well. We're going to use our x and y intercept T-chart. When it's in standard form, that's an easy way to do it. And both the 3 and a 5 are divisible into 15 evenly. So if x is 0, 3 times 0 is 0, this is going to be a negative 3. And if y is 0, this will be a positive 5. So a negative 3, 1, 2, 3, and then 5. 1, 2, 3, 4, 5. Take my line, and there we go. Again, MATLAB graphs very well. Now again, we're going to get a fraction here, so let's solve for y. So we have 5y, transpose this to the other side, a negative 20x plus 15. Divide every term by 5. We get y equals a negative 4x plus, I forgot to put a 1 there, 3. Okay, so there's my y-intercept. 1, 2, 3, a plus 3 right there. Our slope is negative 4 over 1. So we're going to go over 1 this way, up 4. 1, 2, 3, 4. And I could go over 1 this way and then down 4. Looks like we did this one already. But there's our graph. Okay, so we have 2 ways of graphing when they're in standard form. If we're not going to get fractions, we could use that special x and y-intercept T-chart. If it looks like we're going to get fractions, we can solve it for y and use slope-intercept. Now here they're going to ask us to write the actual x and y intercepts. So let's give you a chance. Remember, they're going to be written as ordered pairs. And if it's an x-intercept, your y is 0. And if it's a y-intercept, your x is 0. So we can do that for both of these. X-intercept and y-intercept. So, looking at it carefully here, x-intercept is going to be a -6, 0. And here this is going to be 0, 2. There's your y-intercept, and there's your x-intercept. Your x-intercept here is going to be a -5, and your y-intercept is a -2. Now I've set these up for you. We want you to find your y-intercept is going to be 0, 1 here. And here your x-intercept is going to be 4, 0. Now notice we have two x-intercepts here, so we're going to do the -2, 0, and this is a 2, 0. And here our y-intercept is 0, 4. Now for this one, the x-intercept right there is a 1, 0, and your y-intercept is 0, 5. Now, while we're at this one here, can anyone tell me what the equation of this line is? Well, let's look at it from the form y equals mx plus b. Well, our b value is our y-intercept. So we know that y equals a +5 over here. And all we have to do is put in our slope. Well, this is going from this point over 1 up 5. So what kind of slope is that if we make a little triangle right there? Over 1 up 5. And it's going to the left, so it's a -5 slope. So there is the equation of this, just picking it from the graph. Now if you go down 1, 2, 3, 4, 5, and then over 1, there's another little right triangle. There's all these little right triangles you can make all along where it crosses the grid, and you can figure out the slope. Now, when we are asked in this next page to find the slope of a line, and in some cases it might be undefined, we'd have to see what the slope ends up being, we use the slope formula, which we're calling Formula 3, just to help us refer to the formulas. So this is the formula for slope. This is one ordered pair. This is the other. And remember, we said slope are y units over x units. So we substitute -2 minus our y sub 1 here, which is a 0, over 0 minus 7. So our slope here, as you can see, is a -2 over -7. And since they're both negative, this becomes a positive 2/7 for example 1. Now let's take a look at examples 2 and 3, and we'll have you work on those yourself. Now write the formula out. That'll help you to memorize it. Now as we do formula 2, or example 2, and put it in the formula, we see an interesting thing happen. We have 7 minuses in the formula, but it's a -1 for our y sub 1. So there's a combination of two negatives. So when you see that, you can just make this positive right away. So this then becomes a positive 8. And again, two negatives there make this a positive. And this is going to be a -6. So as we simplify this, this becomes a -4/3. And here, again, two negatives, but they're just subtracting in a sense. So this is going to be a -9 over a +4. So our slope is a -9/4. Now remember, you can put that negative sign in the numerator. You can put that negative sign by the division bar. This is the preferred way. Or you could also write it down in the denominator. This is the one most preferred. All right, we'll give you a chance on 4 and 5. So, setting these up, here we have a -8, and 9 minus 9 is 0. Well, in our lesson we said any time you have a 0 as a denominator, this number is undefined. And if you were to plot this on a graph, which we'll be doing a little later, the equation of this graph would be x equals 9. So it would be a vertical line like so. If I plotted these 2 points, one would be 9, 3, about there, and this would be 9, -5, about there. And if you saw a vertical line graph like this, that's in the form of x equals 9, then the slope of that, since there doesn't show any m there, is undefined. Now as we look at example 5, we do it. Here our numerator is 0, and our denominator is -6. So the answer to this one, this is not the answer. This is part of the work. 0 divided by any real number that's not 0 is 0. So here the slope is 0. Here the slope is undefined. And if you were to draw this graph, it would be an equation y equals 10, and it would be up there through 10 as a horizontal line. So the slope of any horizontal line, or something in this form, x equals 10, is 0. The standard form of this would be y equals b, and we have been saying that b is the y-intercept. And here we're saying x equals a is the x-intercept. And we sometimes see this as an ordered pair a comma b instead of x comma y. All right, we'll see how we're doing here.